So this is my first time to be in beautiful Czech Republic. I'm sorry about that. I didn't do that, right? I always had a great admiration to the scientists from Czech. Fred Janelik, used to be a good friend of mine. If you work on speech recognition, he used to work in IBM, and then he moved to Johns Hopkins University. He's really one of the pioneers of machine learning. He's from this beautiful country. So today, what I'm going to do is really share with you some of the state of the art, what is going on in machine learning, and also what Microsoft is doing specifically to bring machine learning and AI to the public. Let's see if I can move this. Okay, it works now. So our vision is very simple. You can say Microsoft, was a leader for Windows, but we missed the mobile, right? How many of you are using Windows Phone? That's not bad, actually, much better than I thought. That's fantastic. So we didn't really completely miss mobile revolution. But that's okay. Mobile, from our point of view, is about your experience. Whether you are having iPhone or Android, that's secondary. Whether you have the intelligence to enable you to have a better life, to have a more productive experience, that's the key for mobile. So we believe that a new revolution is coming. It's not specifically about the device you have in your hand. It's about the environment you have. Computing will be invisible. So that revolution is really the key. If you want to actually know more about our vision, you can actually go to that. Actually, you don't have my latest slide, I'm sorry. And we have a link. If you search invisible computing on the web, you can probably find the latest story from Microsoft. We shared our vision, what is coming. So in another era, I think computing will be everywhere, will be invisible. You actually have to really have a more natural way to engage with computing. And for natural computing, natural user interface, machine learning is very key, like speech recognition, computer vision, and the natural language understanding. Those are some of the examples I'm going to actually use to highlight the power of computing by machine learning. Okay? So this is a ACM communications article Rajiv Reddy, Jim Baker, and I wrote. We published in the beginning of 2014 in the communications of ACM. That gives a historical perspective of what happened in the last 40 years. So by the way, Rajiv Reddy is a Turing recipient computer scientist working at the Carnegie Mellon University. Jim Baker was his student in the 70s. He founded the Dragon system. If you guys actually have ever worked on speech, Dragon system was really one of the pioneers, and later acquired by Nuance. And I had the privilege working at the CMU as well. That was in the 90s. So three of us really reflected 3 generations of speech research over the last 40 years. We wrote a good review. We thought that would actually, summarize the state of the art. But today, that review paper is already obsolete. That's how fast this community moves forward. So what drives speech moving so fast over the last 20 years or 40 years? On the high level, this really summarizes the 3 driving forces. The first one is really you have to have a stage. For example, I have a stage here. That's why I'm able to really talk to you, even though I'm not a ballet performer. And the stage for computing, for machine learning, for any AI is really the infrastructure, the massive distributed computing infrastructure that enable you to really take advantage of huge amount of data, really dig deeper to get useful information, to get that insight. So that's the first thing. And the massive computing infrastructure, especially using GPU. The second one is really you have to have usage data. That's the oxygen for the performance. You have the stage without the real data, machine learning will not be able to do much. The third column is really the performer. Everyone has different algorithm, method, and deep learning, in my view, is going to change everything. That is really empowered by the stage you have and the oxygen you have. If you look at the historical progress over the last 40 years, this chart from that survey paper really summarized collectively the whole community what we have done on speech recognition. So this is the word error rate. The lower, the better. And the X is the time. You can see, in the early 80s, early 90s, and people worked on resource management task that had about 1,000 words vocabulary and very restrictive. And the research actually progressed very well. Cut the error rate down to roughly 5%. Then people realized, okay, we have to work on more natural tasks. Then they relaxed the vocabulary size from 1,000 to 20,000. And the focus on Wall Street Journal dictation task. And initially, the error rate was very high. But after working on that task for like 3 to 4 years, the whole community collectively reduced error down to 5% again. Then people relaxed further on the constraint. They focused on natural conversation speech. Basically, when you talk to someone over the phone, computer should be able to transcribe your conversation. And initially, the error rate was, this was the red arrow here, was around 100%. That was really considered to be the natural task, because you can talk to anyone over the phone. Computer should be able to transcribe you. Year over year, since the research started around 1993, over the last 20 years, you can see the amazing progress. Today, humans' error rate is about 4 to 5%. If I say, I just ask each of you to transcribe the conversational speech of two people communicating, your error rate will be around that range. If you're not a native speaker, your error rate will be higher. And the computer system collectively is approaching 8% to 7% today in 2016. So if the history can tell us something, in the next 2 to 3 years, computer will be as good as any of you in transcribing speech. That's how powerful machine learning is. That's how powerful deep learning has been over the last 10 years. So this is just one example of the power of machine learning. Just imagine, speech is really the unique faculty we as humans possess. Because of the language, we are different from animals. Monkey, when they see a lion approaching, they know the risk is coming. But any animals other than humans, they would not be able to really communicate. A lion is actually 5 miles away in a corner. So they can organize the group to react differently. The power of language and speech give us the unique advantage. That's why we're controlling this planet. But in the next 2 years or 3 years, maybe it's even sooner, computers will be able to transcribe speech just like what you have been doing. That's a landmark of AI, in my view. So my prediction is based on historical data, as you can see. We are about twice as bad as humans. If we can maintain the same speed, something amazing will happen in the next few years. Do you have any objection? Okay, now at least I got this 200 people group agreeing with me on that prediction. All right. So that's the speech progress. Another progress was last year, Microsoft researcher Mr. Xuedong, and he led the team, achieved really breakthrough error rate reduction, ImageNet. This is a common task. All the bigger companies participated. Over the last few years, Google dominated on the benchmark. Google really outperformed everyone else in ImageNet in the last few years. Until last year, Microsoft surprised everyone. This is really slow to actually. So the Microsoft ResNet reduced error by almost a factor of 2, just in 1 year. So this is really the amazing progress you can see on the common benchmark on the image classification. Basically, you take any image, computer system can now identify what the heck this is about, thanks to deep learning. The latest ResNet from Microsoft Research used over 150 layers of neural nets. That's how deep it is. Because of that depth, they focus on the residual. They actually have the skip over the convolution neural nets. That just had amazing progress. So this already actually outperformed most of the humans on that ImageNet task. Unlike speech recognition, of course, this task is constrained, very much like speech recognition was in the 80s. You had 1,000 words vocabulary or 20,000 words. Here you have about 1,000 image classes. We can further relax the computer vision task. I think the amazing progress is going to be just like speech and the computer vision. So I hope those two areas give you enough confidence on the power of machine learning. If computers can really have mastered your hearing, your vision, what else we cannot do, right? And all those progress, we should thank deep learning. So you might ask, okay, deep learning is important. What is I should do, as a user? So Microsoft had the project Philly. We always use a city name to actually work as a code name on the project. So Microsoft has been really focused on the infrastructure, the stage, to create AI. So whether it's computer vision, speech recognition, or natural language understanding, we have the stage we have been focused on to really enable internal groups within Microsoft to use deep learning, using tool set and the computer infrastructure to perform machine learning. And last year, we decided to share our open deep learning toolkit with the public. I'm very happy to see the GPU leader, NVIDIA CEO, had a blog last year. He talked about how to accelerate AI using their GPU platform. And he named the big four. I didn't pay him to do that, okay? I just want to tell you. He actually wrote the blog. He named the big four. So there's Facebook Big Sur, Google TensorFlow, IBM Watson, and the Microsoft CNTK. So Microsoft CNTK is the computational network toolkit we have been using to train Cortana. And that toolkit we actually open sourced to the GitHub. So if you guys want to actually work on machine learning, you can actually evaluate all those different machine learning toolkit. And you can decide which one you want to use. But I can tell you, the most efficient one is Microsoft CNTK. I know some of you probably didn't believe, but I will give you some benchmark numbers. You can benchmark yourself, okay? So the design goal of Microsoft CNTK is really focused on the efficiency, because when you have massive amount of data, typically, like if you want to train Cortana speech recognition model, it takes 4 to 5 weeks for one end-to-end experiment. So efficiency is very important. If you can really shrink that a month worth of time to train the system to a day or two, then you can actually unleash the power of productivity of everyone. So efficiency and performance are really the key things. So the design of CNTK was inspired by Legos. Each brick is very simple and performs a very specific function. And we can create arbitrary objects by combining many bricks together. So we support both the CPU and the GPU. We support both Windows and the Linux. This is actually really open source. And by the way, how many of you have actually heard about the CNTK? Wow, that's bigger than I thought. That's great. I didn't really need to talk about it. So this is really just CNTK 1.0. We have open sourced. The architecture is fairly simple. You define the computation network. We can optimize this on your behalf and really give you the most efficient run on the money. That's really what it is. And the heart, you define a network node. You define the connection. This is actually, what the CNTK really offers. That can give you the extremely efficient deep learning toolkit that can run across different machines, across different GPUs. I'm eager to actually share with you the benchmark. So last NIPS, we openly shared the benchmark on one of the workloads. This is actually standard feed-forward network. The benchmark script was published on GitHub. So anyone can run this GitHub benchmark against a number of open source toolkits out there. So as you can see, the higher the better, by the way. This is not like an error rate, okay? Do you guys have any question? I want to make this a little bit more interactive, not just, I'm the only person talking, right? Yes? Yeah, this one is not a convolution benchmark. We have another convolution benchmark. So this is a feed-forward neural nets. Now this one is a fully connected feed-forward neural nets. And this is one of the benchmark. If you have a convolution neural nets, because CUDA DNA is so efficient, most people probably will have more or less the same performance on the convolution neural nets. So we did a benchmark on feed-forward, convolutional neural nets, and the LSTM. Recurrent neural nets is where Microsoft CNTK stands out even more than anything else. Yes. We have been incorporating CUDA v5 in the CNTK. That will come. Yeah. CNTK actually we soon have 2.0. And so this benchmark was really based on last year's all the tools out there around the November timeframe or December timeframe. Yeah, right before Christmas. That was our Christmas gift to the public. So, any more questions? That's great. Clearly, you look at this benchmark yourself. Yeah. Did anyone find any discrepancy Was this accurate? I'm sorry? Oh, who knows? You can check yourself. So the task was, published 7 layers, fully connected deep neural nets, and you can just run that script from GitHub. You can download. We can, at that time, we can run this across different GPUs on one single machine, or across different CPUs on the massive connected GPU farm. That was the only open source toolkit. Google clearly matched Microsoft just recently. So TensorFlow is now able to run across different machines now. But once again, you guys can go and benchmark TensorFlow against Microsoft CNTK. Let the result speak for itself. So we just joked the CNTK really was the Cinderella story. It was extremely fast inside, but most people, they don't know. So here in the Czech Republic, I'm just telling you, CNTK remains the most efficient deep learning open source toolkit available for anyone to use or contribute back. Okay? How much time do I have left?
30 minutes.
Well, I need a pointer here. So Project Philly is really the infrastructure Microsoft has been using and developing internally. And the CNTK toolkit is a small part of that Project Philly. We already decided to open source that tool to share with the public. So you guys can really take the tool, take full advantage of the most powerful weapon we have for your own needs, for your own task. Yeah, because deep learning, in my view, is going to change everything. And Microsoft used the CNTK to train Cortana. That is used in Windows 10. That's actually our state-of-the-art speech system. Okay? So the second project, I'm going to talk about only 2 projects today because I have a limited amount of time. I think tomorrow we're going to actually discuss Azure ML. That's really a third project that Microsoft has to share with the public about machine learning. So the second project I want to talk about is Project Oxford. We officially renamed Project Oxford as Microsoft Cognitive Services. But if you go to projectoxford.ai, that will direct you to microsoft.com/cognitive service. So what this is about the democratized AI. If you use CNTK, Project Philly, you want to get a lot of data to train your system. That's still very expensive. Where do you get all those GPU, right? We have hundreds of GPU, and you have to gather 100,000 hours of speech, label the data to really create anything that's decent. So it's still expensive. So what we have done is really we packaged all those Microsoft-trained AI models and shared with them in the form of REST API. So any web developers can really take advantage of Project Oxford, just use Microsoft AI. That's actually really 20 years cumulative R&D with 1,000 people, and create your own intelligent applications. So that's what this is about. So it's about adding smart to your own application. If you're a web developer, you want to do machine learning, fantastic. If you don't want to do machine learning, you just want to consume machine learning, Project Oxford is the tool for you. So, it is, I already said that in everything in the slides here. So, essentially, I need to point on this way, I'm sorry. Computer vision, we have a set of computer vision APIs. And have you actually heard about HowOld.net? You basically upload your image. That application will tell you what your perceived age is. How many of you tried of that? It's a small amount, but you guys can just go to howold.net, upload your image. You actually see, how you are being perceived by your peers. Okay? So that's actually powered by the Face API from Cognitive Services. And we have Emotion API as well. So basically, you can upload the image. We can tell you whether you are jealous, angry, or happy. And of course, we have Speech API. Essentially, what is being used by Cortana is actually exposed through Microsoft Speech API in 18 languages. I'm sorry, we do not have Czech language yet, but we do have 18 languages. We also have a speaker recognition, and this is essentially very important if you say you want to have a second stage verification, you want to log into a web services, you can use voice as an alternative. The third one is really the most important one. Taking Microsoft Cortana language model, speech model as is, usually is for general purpose, well-defined microphone. If you have your own application task, it will not perform well. Let's say you have a medical dictation application. If you take an existing Microsoft speech recognition model, because of the vocabulary mismatch, or you have the term mismatch, it will not perform well. Custom recognition intelligent services in Oxford, we actually call that CRIS. We enable you to really upload your own vocabulary, text material, or even acoustic model to customize the default speech system to fit your own needs. And this is actually one of the most popular services we have right now. Is by invitation only in preview, but it's very, very powerful. Usually will give you up to like 30 to 40% error reduction, because you can tailor this whole system for your own needs. And of course, CNTK is being used in the cloud on Azure. But you don't need to worry about all those recipes, how this was done. You just upload your own data, your own vocabulary, just let it run for maybe a month. I'm kidding. And if you have a lot of data, that will take a month. But then some magic model will just come back to you with a stunningly better performance over existing Microsoft Cortana. So on the language side, we also have a range of services that's in Oxford, like spelling check, language understanding intelligent services we call LUIS. And what the LUIS can do is actually very powerful. Essentially, will give you the tool to understand the intent and the entity of your domain. So if you want to create a solution, and your own application that has the capability of Cortana or Siri or Google Now kind of capability for your own task. With Microsoft Speech, CRIS, and the LUIS, you can create a system that is as good as the state of the art, because the recipe of how we created Cortana is here. What you need to do, just really get the data ready, and label a few examples using active learning. You can actually have the whole end-to-end system fully competing with Google, Apple, or Microsoft. So here we have some examples of how Microsoft Cognitive Services API are being used. So if you upload an image, we can tell this is a person, where the person's face is. That's all done automatically. And we have the perceived age of 27. We know this is a male swimmer. So that's actually a very simple API call. You upload the image, call this REST API. You have the entity give you all those information you need. So that's the example of input and output by using a REST API, calling Microsoft Cognitive Services. Okay? And also, you can also say, if this is a porn or not, and adult content, we can actually give you that information. Because for business enterprise application, that's very important. Nobody can afford to upload an image that's a porn image on your website. Through Microsoft API, you can actually automatically detect whether this is porn or not. So on the OCR, you upload any image, the content of the language can be actually automatically recognized. And once again, what you need to do is we just call Microsoft Cognitive Services API, and all the heavy-duty machine learning to perform OCR recognition, to segment the image, where the word is done automatically for you. And here, that's just another example of the, JSON output from using Microsoft Cognitive Services. It's extremely good to scan the documents, photos with text, fine-grained location information, etc., etc. Of course, there are other things you can do, the small thumbnail. This is actually the most fun part of Face API. We can detect where the face is. We can perform face verification. And you can do a similar face searching. You can have face grouping. And of course, face identification. So that's just one example of using Microsoft Cognitive Services Face API. We detect this is, where the face is, with that face rectangle location. You have an attribute, age of the person, 42, gender of the person is male, and head pose, where you are looking at. So you can just imagine what kind of potential applications this is going to be if you want to create intelligent applications without doing machine learning yourself. You can consume machine learning results. Now the fun part of course, is the motion API. And you can just imagine yourself, you can put the camera in your house, just watch your spouse, and whether, and the happy index is high or no. If it's low, just keep your mouth shut, right? So there are unlimited applications you can develop by using these cognitive services. So we have 7 classes, roughly. You can just upload any image. We can automatically detect, find out where the head is, and give you the emotion status. And there are video APIs for stabilization, face detection, and tracking for security application, and the motion detection, etc. So that's also part of the Microsoft Project Oxford. So those examples are really showing the power of machine learning, because none of those services was done by simple computer programming. They are from years and years of deep learning, machine learning research, and a huge amount of data we have accumulated by using CNTK kind of technology in the background. So I want just actually 10 minutes? 20, okay. So because speech is almost my favorite subject, I want to actually spend a little bit more time talking about the speech in Project Oxford. So for voice recognition, there are 7 languages right now in Project Oxford. Actually, I think we're expanding that to 18. You have REST API. You also have a client library on both iOS and Android. Of course, Microsoft Windows is included. But you can see Microsoft really focus on the cloud-centric AI and this cross-platform. If you have iOS client, you can easily use the client SDK to develop your own speech application. So I don't need to really further explain this. It's very simple. You just upload your audio to the REST API. You can get the recognition results out. Of course, you have to specify the language, whether it's long form or short form. We also have computer synthesis. If you have any text, you want to actually have a computer to tell you what it is, you can have the computer TTS, text-to-speech API, for voice output. For speaker recognition, and there are two applications. You can validate if the speaker is the right speaker, or you can actually look for the speaker. So that's the verification and the identification task. This is very powerful for security applications. Now, let's talk about the Chris. I already said, any general purpose speech system is not good enough. So you need to really customize for your own domain. This is extremely powerful. We also believe this is very unique. So I can tell you, actually, one of the large companies in the US gave us a huge amount of data, and they are really realistic data. That's not the same as what we have targeted. What we have targeted is really you have mobile devices. You talk to your phone, you get the recognition. But the application we have is really, you drive through this device, you want to talk to the device, and you are in a car is running, so it's very noisy. You're also far away from the microphone. So if you just plug in Microsoft Speech API as is, your error rate would have been 80%, not accuracy. You basically, nothing actually really works well. But if you use Chris, you record a lot of audio in other contexts. It's very noisy for talking. You also know the vocabulary kind of things. Think about that's an e-commerce application. We actually have seen the error rate was reduced from 80% down to 20%, down to actually further if you just do the fine tuning. That's the kind of power of Chris, because you can just customize the whole system by collecting your usage data, by feeding the oxygen to the system. That's what I just, I have 3 columns, right? I talk about the stage, oxygen, and the performer. If you have usage data, you simply feed into Microsoft Chris, bingo. All the heavy-duty machine learning is done on Azure by us. And then you have this stunningly beautiful system. You can reduce error. You can reduce basically error from 80% to 20%. Actually, we have I cannot disclose the name of the company, but I can tell you the case. It's just amazing to see how powerful this Chris really is improving the usability. So that's the process. You record audio, you transcribe the audio, you feed it into Chris. Magic just simply happens. I'm not sure if you feed the check audio data, that will happen. I'm just, we're not that powerful, but actually for the same language, if it's different application, different domain, this is just simply amazing. I will skip spell check API, but that's also available. This is also something I personally worked on when I worked in Bing. And if you type into a search engine, you can see that most of the typing typos can be automatically corrected because we have billions of typo errors we can learn from the real usage. So we have accumulated a huge amount of data, and we are also exposing that deep AI for the public. So Louis is another thing. I think if you want to create an IoT application, you can take a quiz, customize for your IoT usage scenario, and that only will perform recognition, give you transcribed data of the word. But what really matters is really you have to understand the entity and the intent, so you can really perform action against what the command should be from the user, right? So Louis is really the tool you can use to create a language understanding services. So we have packaged a set of pre-trained templates from Bing and Cortana. So you can start from actually the building blocks of Microsoft search engine Bing, and then customize for your own domain and your own application for understanding. We basically, what you need to do is define a set of concepts, intent. So if you say you are creating an application of your own, what kind of actions you want to perform. And when you perform the action, you want to actually provide a few examples. Through active learning, Microsoft Louis will actually enable you to label the data with a small effort. And magic will simply happen. So rather than label the data, we have active learning in the background, will give you an amazing, accurate natural language understanding system. And if you have internet access, go to louis.ai. You can actually sign up to perform language understanding tasks. So once you actually perform that task, then the output will be entity. For example, could be flight delays on the topic. If it's actually a news about the flight delays, you have the intent. You see, intent is find news, and then none with different probability as output. And this is actually the UI on how you should label the data. So basically, for a few examples, begin, I cannot read it. You label the entity. You mark what that is. So any actually people, not necessarily developers, can use this tool to create the label to enable machine learning to perform natural language understanding. And you can also use a pre-built entity from Bing and Cortana. So you don't need to really, if there's actually, for example, a time understanding module, you can just use that as is. If there's a weather module, you can use that as is. And you can just customize everything for yourself by defining intent. You can see the first one is intent. You have a set of intent actions to perform. We can recognize from natural language what the intent should be, and then you define the entity. Because entity and intent combined, your computer program can perform any action. So that is the UI of Louis for you to develop powerful natural language understanding application, just like Cortana or Siri or Google now, because essentially they use the kind of underlying technology for the same task. But this one will give you the powerful tool to customize your own application with an intelligent interface. So he reminded me I'm running out of my time. I want to reserve 5 minutes for question and answer. And I want to just quickly end here. There are a number of application showcases by using Microsoft Cognitive Services. Behind the door, we use the CNTK to enable deep learning to create those models. So those two combined will democratize AI. You don't need to have 1,000 people working on this for 20 years. You can just, use the REST API to call into Microsoft Cloud Services and make your own application as intelligent as anything you can find in the marketplace. So on the Project Oxford, here's a number of links you can go to take a look. I think we are roughly, with all the deep learning, reached the level of mouse of a rat. So we still have a long way to go to reach the level of AI of human brains like you and me. But that's exciting time, and despite the current IQ is like just a rat, it's still useful. Okay, thank you very much.
Great talk. And now we have like 10 or 12 minutes for questions.
Yeah.
So please ask.
Hi, thanks for the presentation. I just wanted to ask, on the second slide, you showed the way that accuracy progresses for different tasks. And it looks like that even for the simpler ones in the 80s and 90s, there was a wall. They never went below, say, 3-4%. What do you think about those last 3-4% for those tasks and for the tasks we have now?
That's a good question. I think that for some of those tasks, they can be below 4 or 5%. Just people start looking on that. Because if speech recognition accuracy is above 95%, it's highly useful. And people also want to take a more challenging task. Let's take the switchboard task as it is. Even for humans, the error rate is around 4%. So it doesn't make a lot of sense to beat the dead horse. Yeah.
Okay, another questions?
No, thanks for the talk. I was wondering where these services will be available in the Czech Republic, because Cordana isn't currently, I think. So,
I missed you all, because my error is actually 4%. I'm sorry.
Sorry. What about the availability of such APIs in the Czech Republic? Because Cordana isn't available here currently.
In
Czech Republic, yes.
I really have no comment. I do not know, our language. We are being prioritized by Windows team, and I'm working research. Basically, they decide which language they want to support first. It's not up to me.
I'm not interested in language. Like the language I want to use is English, but it's limited by country. Not
by country.
Yeah.
And I think that you can work around that problem. Just get a US credit card. You can. Seriously, I have a friend of mine who is actually developing this application in Israel, similar to your situation, and Azure API services is not available. And then he got a friend of his in the US, got the US credit card, signed up, then developed the application in Israel.
Yeah, but still users can use Cordana here, so I can't force my users.
No, Microsoft Cognitive Services is not really tied to Cortana. It's tied to Azure. So I don't know if Azure services is available in Czech Republic. We have, let's see, do you guys know if Azure is available?
Yeah.
It's available. Then you can, in theory, you can access cognitive services. Essentially, it's tied to Azure Marketplace. If you cannot actually make that work. Get a US credit card is the easiest solution. People have done that. Okay? What I said is not official. This should be off record, okay? I don't want to get myself into trouble.
Hello. Thanks for the nice talk. I got a question.
Sorry?
Are you going to, or are you currently reusing the data that you got from the developers in your models?
No. If you say you are using
The customized speech or
customized speech model is actually for your own use, unless you are willing to share that with Microsoft. Microsoft has no access to whatever you want to do, unless we specifically, spell out we want to access the data to improve model. We'll give you users the option. So we're taking data privacy very seriously.
Thank you.
Back at how.net, we got 500 million probably, 500 million roughly, images uploaded, and we have no access to that data. Yes?
Hello. I would like to ask about, when you spoke about the distributed version of your platform, if you could briefly explain how the problem is divided, what you communicate between the nodes, and how you
For
see
CNTK.
in your platform, yeah, for the SDK, how you synchronize the neural network across multiple nodes.
So for CNTK, I assume your question about how you use the CNTK across different machines.
It's rather how you do that.
Yeah. So CNTK has a multiple options. We have a parameter server. You can use asynchronous SGD across different machines. So there's a parameter server. You can actually jointly optimize. We also have very unique technology. We call it one-bit SGD. Basically, when you update the gradient, you just need to get the direction information. You don't need to really share all the deltas across different work nodes. And we have a unique Microsoft one-bit SGD technology. That's how we actually can be so much faster than any other tools available out there. Yes, that's actually the secret sauce. It's CNTK unique, and other open source cannot copy that because we require this as even though it's open source, but it's tied to CNTK. If you use CNTK for developing commercial application, it's okay. If you want to copy that in one bit SGD into, let's say, Torch, you cannot do that. Okay? Yes?
What's the business model behind offering these services?
Business model for CNTK or for cognitive services?
For any of them?
Cognitive services is actually not free. And if these are Azure services, to a certain level, it's free. But if your traffic is above, let's say, 5,000 queries a month, then you have to pay $4 for every 1,000 queries on speech. So that's the business model. We want to bring people to Azure ecosystem, and to operate these cloud services is very expensive, so we want you to share that cost. So that's one. For the CNTK, it's research toolkit. If you are a serious machine learning scientist, we feel there's no need for you to recreate the tools. So you can use Microsoft tool to create your model. So there's no business. It's really community service from Microsoft. It's all about goodwill.
What do you think about sub-area of speech?
I really feel the speaker here is very lousy because it's hard for me to understand. I need to get off.
What do you think about sub-area of speech processing like voice conversion, about this future? Voice conversion.
I got a echo from those two speakers here. Can you just repeat the question? It's hard for me to understand.
What do you think about voice conversion as a sub-area?
Oh, I see. What do I think of the voice conversion? I think it's a very unique application. I don't think that's in the cognitive services yet, but I think it's very interesting. We do have technology to really customize Microsoft TTS into one individual voice, but that's not public yet. So that's actually in-house R&D right now. So in theory, if we can collect enough data of one person, we can create a character. And you can type anything, you can feed anything, then this Microsoft TTS service could speak like that person. Even though emotionally it may not be similar, but on the common sentences, it will be actually fairly close. The hardest part is really that last mile. Whether emotionally this voice is just like the original speaker. Also, they are legal concern, so that's why we do not have that services out yet. That's the voice conversion, right? If you can really say, create a voice of you, I can type anything, it will speak like just you. And if I can create a voice of her, then you can say, you can easily convert between two people. Yeah. So on the stage, my human understanding error rate is actually really high because of those two speakers just keep, giving me echoes. Any more questions, or do I have enough time?
We have time for a couple of questions.
Okay, we will continue to have this dialogue. So the question is, what is the reliability of speaker recognition? Identification, I see. So the state of the art of equal error rate means the false alarm versus the false acceptance is under 1%. That's actually fairly good, under 1%. Yeah, there's for speech recognition, how frequent we update?
Yeah, and how hard it is to, because you say like it takes months even with reviews, so how often can you do this?
The default model actually will update very frequently. And if you use Chris, we put the control in your hands. You can update the model anytime you want to. Because Chris custom recognition services, you are in control. You can customize language model, customize acoustic model all by yourself. By feeding data to Microsoft Cloud, then you have your own version of autonomy.
Is that your own?
Our own really, that depends on this, when we can have a major improvement. So could be 1 month, could be 3 months. It's seamless. You cannot actually tell the difference.
Here.
Yeah.
I'm just curious for
I have 2 speakers going in the wrong direction.
I'm just curious to find out. All right, I guess you can hear me, right?
Yeah, I can hear you. Without that one is even worse.
Yeah. So I'm just curious to find out, like, for a developer that's new, that's not an expert on deep learning, how much of a black box is your system? Is it just, I provide my data, I get the output, or do I get a lot of say and control and all the different knobs and the 150 different layers? Do I need to know the theory, the math behind it? Because deep learning has a little bit of like an interpretability problem, right?
So that's a very good question. His question is, if you are not an expert in machine learning, and what does it take for you to really understand the math behind it, to really get a good model?
Or do I even need to, right?
And or whether you need to. I think if you are an expert, you will actually perform better. No question about that. But if you're not an expert, you have more data than the expert, and those data are accurately labeled, you can still outperform the expert. So there's no simple answer. Because for deep learning, without data, you're nobody. If you have the equal amount of data, you're an expert, and against another non-expert. Then it really depends on how much CPU time you have. Because to tune the parameter, what we call hyperparameter in machine learning, there are so many of them. And you need to run a lot of experiments to find the optimal point. So even if you're an expert, you still have to tune a large number of parameters. Of course, you may not need to tune as much as a non-expert. A non-expert, if you have no idea where it is, you can still perform gradient descent, identify, where the optimal point is. So that's my answer. In general, if you're more experienced, you can probably, get the results out faster. But there are so many things you have to prepare. The amount of data, computing resources, then zero in on the parameter tuning. You need all of them. So even for non-expert, if you just read the basic instruction, you can still actually reasonably perform a good result. Of course, Microsoft has the scale. You have the CNTK toolkit. You just consume using Chris, for example. You don't need to do anything. You can still use Microsoft AI. But if you have your own application that Microsoft doesn't offer, you can still use the CNTK. With a reasonable effort, you can actually get a good system.
And in addition to CNTK, ML is another Microsoft machine learning toolkit. So it has a broad set of machine learning library you can use. But the CNTK is specifically just for deep learning. Okay?
Okay, thank you very much. We have no time
But two
for
more.
other questions.
Just one more. So the question is, I'm just repeating, Microsoft provides any program to support the developers to create their own application, right? And I don't think we have any financial program to motivate the developers to create application. What we did is we offered the free tier. So if you just want to perform your services using Microsoft Foundry services, they're free. So I hope that's motivating enough. Because you will have really access to 20 years of cumulative Microsoft AI research and development. That's actually really, a huge asset you can tap into, and you can see what the state-of-the-art AI can offer you. And if you really reach, the level of traffic, and you can still come to Microsoft to request, the support at that time. I do not know, what kind of programs we will have in the future, but at this stage, you have free access to Microsoft AI.
Okay, thank you. Thank you very much.
Thank you.